In this next module, we're going to discuss for Cisco ACI what is the virtual machine management and how do we, with Cisco ACI Fabrics, interact with virtual machines. So we're going to begin by discussing and going over a primer on virtualization. So many of you have worked with plenty of virtualization platforms, probably most notably VMware, vSphere, and ESXi, possibly also Microsoft Hyper-V. But there are many network engineers out there who have not done that. And with ACI, this class being primarily targeted at the network engineer, although certainly applicable to all students, we definitely want to go over a little bit of a primer on that and make sure that everyone is up to speed and understanding how virtualization works, both in terms of physical virtualization, but then also in terms of what some are loosely calling virtualization, which it deals with containerized technology, and make sure that everyone understands that so that as we begin discussing a lot more how ACI interacts with this, it will make a lot of sense. There's a lot of data centers out there today that have gone to a high degree of virtualization for their servers. Some completely virtualized, but very few 100% virtualized. And of course, ACI can really address this with having support for both virtualized machines or VMs, as well as physical bare metal VMs, hardware-based routers, and virtual-based routers, and other things, load balancers as well. So we'll be taking a look at some of those other things, layer 2 bridging, layer 3 routing, and even layer 4 through 7 virtualized services, such as firewall and load balancer, as well as physical in the next few modules. But to set the stage for all the virtual services and routers, and even just regular, the mass amount of nodes or end hosts that we have on our network, which are the virtual machines, we want to take a look at this. So we'll take a look at a hypervisor integration overview. We'll take a look at integration with VMware, both with the traditional method, and then we'll also look at the ACI plugin method. So with the traditional method, we'll look at the integration with the VMware VDS or Virtual Distributed Switch, or VMware Distributed Switch, whichever you want to call it, as well as how we configure both ACI and VMware. We'll look at the ACI plugin as well, and we will take a look at how to configure this as well. And then we'll begin looking at, this is going to be a fairly long section. This will probably be broken down into multiple modules. So we'll probably pause, and in the follow-up Part 2 module, we'll take a look at the ACI integration with Microsoft Hyper-V. Then we'll also take a look at an integration with OpenStack, and what is the OpFlex protocol and how does it play into virtualization. And we'll take a look at the application virtual switch, which is Cisco's virtual switch that runs in hypervisors. We'll talk about a few design considerations, and then we will take a look at the future hypervisor integration roadmap and where we stand on that. So let's begin with a primer in virtualization. So over the past 10, 15 years, servers have evolved, right? We used to run a bare metal server with its hardware, for instance, network card, memory, disk, whether SSD or hard, spinning, and CPU processor. And we used to build our operating system directly on the hardware and our binaries or libraries, as well as possibly multiple applications directly on hardware. Now, we still do this in many cases for many different things, especially when it comes to raw performance, such as databases is typically a large driver of this usage of bare metal machines. But one of the things that we had in the IT department, let's say in the late 90s, early 2000s, was the need to have, or really to maximize your cost, right? Your return on investment. So say I invest in a really beefy, and 2000 we're talking about maybe a dual Xeon processor of actually dual Pentium 4 or something like that. Maybe Xeon had just, anyway, I digress. So we're looking at making sure that we're using our hardware efficiently. So a lot of times people would put multiple applications on top of a single piece of hardware. For instance, maybe I'd build a Microsoft Active Directory server, and the company would say, well, why can't you build Exchange on there as well? And while you're at it, put Microsoft SQL Server on there. And of course, there are sometimes conflicts between different dependencies, which are the binaries or libraries. In Microsoft world, the DLL, the dynamic link libraries. Sometimes there are simply phenomena, strange things that happen when we put too many apps on one bare metal server. So of course, the idea was, let's go ahead and isolate all the applications, each to its own bare metal server. Well, that was fine and all, but then we had to buy a lot of bare metal servers. We had the sprawl of what we call pizza box servers, the rack mount servers where the top flips open, so we call those pizza box. And we had this sprawl of hardware. So in comes virtualization, and the idea is to take the hardware and abstract it away from the operating system. So we put a hypervisor on top. So this is kind of like it started out as really a bare bones kernel Linux operating system that would abstract the hardware. And of course, this is now become, with all the major vendors, quite their own proprietary operating system. It's no longer just Linux or anything like that. But we abstract away the hardware from the what looks like an actual machine. So on top of that hypervisor, we build a full virtual machine. So we build our operating system. Maybe it's Windows Server 2012, for instance. And we put our dependencies, our binaries and libraries, and one or possibly multiple applications, typically one application on there. And it looks to the operating system like it's talking to a physical machine. Now, of course, in modern days, operating systems know that they're talking to virtual machines, and they're perfectly fine with that as long as it's supported in your OS or in your application. More typically is where the dependency is. But originally, the idea was that the operating system would have no idea. So then we can build multiple virtual machines or multiple operating systems and maintain the autonomy of running multiple operating systems, maybe all Windows, maybe all Linux, maybe all Solaris, maybe a combination of all of those. It doesn't really matter, and that's the idea, is that we can have multiple operating systems on top of a single piece of physical hardware. So they're all sharing the same, let's say the same two core sockets for CPU and 12 cores per socket. So we have 24 cores that can be distributed or used or really presented to the various operating systems. Now, when we present those, we may present only a few cores, or we may allow the operating system to access all of them. And that's really the beauty and the power that we have at the hypervisor level, is we can control, when we build the machine, the virtual machine, what they see. Okay? So we can also upgrade those a little bit later as time needs, or as the operating system or application demands. We can add more memory. Now, as long as we have enough physical memory, we can add more virtual memory. Same thing goes with network cards, which is what we're particularly interested in here with the networking side. And ACI is we could add multiple virtual NICs, or vNICs as we call them, as long as we have enough physical NICs. Now, one of the things that we'll take a look at in this module is these may be physical NICs, meaning this virtualized server, this hypervisor, might be running on a rack mount server, or it might be running on a blade server. And in either case, we may have one physical NIC or two physical NICs, or even a CNA, a converged network adapter. Or it might actually have a virtualized card, which is still a hardware-based network card, but it has the ability to do either what Cisco calls VIC, so the virtual interface card, and do virtualization of the physical network cards. So this is a separate virtualization that we're talking about. We're talking about virtualization at the hardware level, done in either the, let's say for instance, the C series, like a C220, or the B series, maybe like a B200 or a B22 blade. At any rate, this is actually virtualized before it's presented to the hypervisor. So we might tell the hardware NIC card or VIC card, the virtual interface card, that it is actually presenting 12 different virtual cards to whatever the operating system is. And in this case, it would be a hypervisor like, let's say, ESXi for VMware. Or it could be Microsoft Hyper-V, it could be Red Hat KVM for OpenStack, could be a number of things. So then the hypervisor would take what it thinks is 12 network cards, and it would create one or more, sometimes we want 5 or 10 virtual network cards, VNICs, to the VMs. And it doesn't have to be a one-to-one correlation. What we're doing is mapping things. And this is very important to understand from the virtualization standpoint. So in fact, let's just take a brief look at a whiteboard, and let me actually just get rid of this drawing. Start with a plain whiteboard. So what we might have at the server level is, let's say that this is our, actually let's draw this a little bit lower. Let's say that this is our bare metal server, and it doesn't matter whether it's a C220, C-Series chassis or rack mount pizza box server, or whether it's a blade server, maybe a B22, something like that. As long as it has a Cisco VIC card, and similar in the industry standard would be SRIOV, single root or server root IO virtualization. But let's say it's a virtualized interface card that we have, and what we're presenting is, let's say we're presenting ... We're presenting, let's say, 8 network cards. So we present 1, 2, 3, 4, 5, 6, 7, 8. Actually, you know what? Let's make this a little bit more simple. Let's just present 4 NICs. So 1, 2, 3, 4. And these are presented to the actual hypervisor layer. So maybe here at the hypervisor, that's kind of a color that's a little bit hard to see. So maybe here at the hypervisor, and we're going to actually be taking a look at VMware ESXi to begin with, so we'll just use that as an example. VMware ESXi, it sees the 4 NICs, and it uses those as its downstream, what it calls VM NICs. So each of those correspond directly to one of these presented VICs. Now the VIC card itself, the physical VIC card, only has 2 uplinks if it is a C-Series, but if it's a B-Series server, then really this could have as many uplinks as we want. So we present those on something called the UCS Fabric Interconnect. And that's sort of the switch that goes in between the blade, if this were, let's say, a B22 blade or a B200 or some other blade, and the upstream network. So actually probably should have left myself a little bit more room. And I'm going to draw my VMs up here. So I'm just going to draw the Fabric Interconnect down here. So the UCS Fabric Interconnect. And of course we would have a pair of Fabric Interconnects, but I'm just drawing one. And then we're actually going to have our network switch. So let's say this is our Nexus 9 9300, and let's say this is Leaf 101, for instance. Okay, so we have this mapping, and we could map, let's say we have a Fabric Interconnect with a pair of, let's just say we have some uplinks, maybe they're port channel, maybe they're more likely VPC, virtual port channel, to a pair of Leaf switches. And let's say we might even have, for some reason, multiple uplinks, and maybe they're going to the same leaf, maybe they're going to different leafs. And the reason might be something called disjointed layer 2, and maybe we're using one for a backup network and one for our primary traffic, or maybe we're using one for our management traffic, where maybe our management traffic from the FI goes to an out-of-band management switch, which is not ACI. We certainly can run our management traffic over ACI as well, but maybe we have another uplink that's going there. So our first 2 NICs we're going to map over to our management, and our second 2 NICs we're going to map over to our uplink for data to the rest of the ACI fabric. So then when we present these to our VMs, I have my first VM, I have my second VM, I have my third VM, and I also need to keep in mind that I'm not just presenting these NICs or virtual network cards to the virtual machines, but I may also need them for, and I will also need them for, to be more specific, the ESXi management itself. So we do this through interfaces called VMKs, or virtual machine kernel interfaces. VMK0 is always there for management, and we may have more VMK1, maybe for fault tolerance. Maybe we have it there for a separate one for vMotion. And some of the things we'll be talking about, not necessarily in this module, but in later ones, is how do we run ACI, or actually how do we run our ESXi management in band? So we actually run it on the fabric, the ACI fabric, rather than running it out of band. Another thing is, how do we run our vMotion in band to the ACI, meaning we're running it on our leaf and spine switches, and make use of all those, great, pull this up here. If we take a look at it more from this perspective, how do we make use of all of these fast, either 2 if we have 2 spines, or 4 if we either had 4 spines or 2 links to each spine, 40 gig L3 equal cost multipath, all links forwarding, 40 gig, interfaces. So if we had 2 80 gig, if we had 4, 160 gig, how do we make use of all that by allowing vMotion, which is very bandwidth hungry, to route over there? How do we do our ESXi and our vCenter management all over there? So we'll be taking a look at some of those as we go on. So again, we're going to present up to our VMs one or multiple of these interfaces. Maybe we'll present the same NIC up to all of them for one particular set of VLANs. Maybe we'll present another one. But again, they don't even have to be a one-to-one mapping. So I could have, let's say, 3 NICs, one for primary usage and all my primary routing, one for, let's say, backup, and one maybe for monitoring. And maybe in some of them I just have 2. One for management and monitoring, and one for on all my regular data, and then one for backup. And in some of them, maybe I only have 1 NIC. And at any rate, whether I'm only presenting 2 of these, or even just 1 of these up here, the idea is that these are my physical NICs, and inside my hypervisor, I'm actually going to have some sort of a VSwitch. And we'll be talking a lot more about these. So some sort of a virtual switch, not just our physical, maybe Fabric Interconnect, which can be considered a switch depending on the mode it's running in or depending on the capabilities we're using at the moment. Certainly but it's still more or less looked at like a layer 2 switch from the perspective of the hypervisor. And then certainly the ACI fabric, okay, the actual leaf and ultimately spine switches. So before we get to those hardware switches, we have to have some sort of a virtual switch that passes traffic from these virtual NICs on the VMs and even the VMKs for the ESXi host itself onto these NICs, whichever physical or virtual NICs, and when I say virtual NICs, I mean the Cisco presented VIC or virtualized interface card NIC. So there are multiple levels of vNICs, and I know that can get confusing. I'll try to present a little bit more of a simplified drawing that I've pre-mapped out in a little bit. At any rate, how are we going to present these? And how can we have more? Let's say I'm only presenting 2 of these, or maybe I had only ever created. I need to increase my eraser size there. So maybe I had only ever created 2 NICs to begin with, and they were not mapped over to my management switch, but they were rather just mapped to my uplink, to my leafs. So if I only had 2 vNICs, how could I actually ever present 3 to a virtual machine? Well, again, these are looked at as the uplink ports on this vSwitch. And so these uplink ports differ or are abstracted or are separate from the ports that we see on the switch that go to the VMs. Okay, so this would just be like having multiple ports on the client side or the access side of a switch, and then having my uplink ports. And essentially, we just put these into VLANs. And we can also use VXLAN here at the VSwitch, and we'll talk about that a little bit later. But let's just say we're using traditional VLANs or VLAN IDs. We would assign a VLAN ID, and this would be, these ports here would be more like, in fact, let me just change my color so it's a little distinguished. These ports here would be more like our switch port mode access. Okay, switch port mode access. And then these ports down here would be more like my switch port mode trunk. So when these ports down here that are switch port mode trunk, as long as they're trunking all of the VLANs that I'm using here, so for instance, if this is switch port mode access and switch port access VLAN 10, then as long as these ports here are trunking VLAN 10, and these ports in the blade system in the fabric interconnect are trunking VLAN 10, then we'll make it all the way to the leaf, and we can have these abstracted or more than multiple VNICs at the VM level. Okay, so we've taken a little bit of a look at virtualized servers, and we're still going to, of course, need our physical uplinks from our ESXi machines to our leaf switch. And as I mentioned, if this were a blade server, then we would actually have another intermediate device, which would be the fabric interconnect. So I talked briefly about the VSwitch and how that's going to be used to connect our VNICs down to our physical NIC. Now we might have, and we will most likely have, multiple hypervisors, each with their own hardware, their own blade or chassis rack server, their own virtual machine, and their own vSwitch. Now, when we have these switches are independent of one another. So if we create port groups, which specify the VLAN ID for a given VNIC on a given virtual machine, we have to create these port groups multiple times. Let's say we have 100 ESXi hypervisor servers. Then we have to create the port group for, let's say, virtual machine A that's going to be on all hypervisors. We have to create it 100 times. So VMware and Cisco actually together back in 2008, 2009, got together and spent about a year and came up with a few things. One was the Nexus 1000V, which was Cisco's virtual switch, and at the time helped VMware to understand networking better, and came up, basically helped VMware to create the API and the infrastructure for what's called the DVS, or the Distributed Virtual Switch. And you'll see this presented as either DVS or small v uppercase DS, so VDS. They're the same thing. If you see VDS or DVS, they're the same thing. So DVS is your Distributed Virtual Switch. VDS is essentially your VMware Distributed Switch, or the API architecture. So this is still, there's no physical connectivity here, of course. We're not literally or physically connecting servers together with 10 gig cables. This is just a virtual switch that is the software, or the programming is done from a central place, which is the vCenter server. And you do have to have the Enterprise Plus, so the highest level of licensing, in order to support this. So that is one thing to note. But essentially, when you create a DVS and you join these hosts or hypervisors to that DVS, the hosts are already joined to the vCenter, but now you join them to the DVS, then any port groups that you create on the central or single DVS automatically get propagated or pushed with all the information, whether they support CDP or LLDP or none, whether they support how the port channeling is done if they have multiple links. Are they doing LACP, which VMware calls IP hash, whether they're doing MAC pinning, which Cisco calls MAC pinning, what VMware calls originating port ID. All of that information, including the port groups, the VLAN IDs, all that gets pushed down to each ESXi server. And then I only have to create a port group once, and then I can consume or go to any virtual machine and use that port group on any ESXi machine that's a part of that DVS. And you can actually have multiple DVS, or multiple distributed virtual switch, per vCenter, and even running on a single host. So it's fully supported to have a VSwitch, or what's also called VSS, VMware Standard Switch, the local switch that's always there, and even multiple local VMware Standard Switch, or VSS, on a hypervisor, and one or more DVS. So this is all possible. Now, something else, oh, sorry, here we go. So this is a kind of yellow animation around a VNIC to indicate a port group, red to indicate a separate port group or VLAN ID, and then the fact that those port groups are then trunked up through the uplink, which VMware, as I mentioned, calls the VMNIC, and then through the physical hardware, whether it's virtualized or not, and then up to the leaf switch. So those would be our .1Q VLAN IDs being trunked up. Now another option, and something that's not necessarily VMware in any way, VMware's begun to support them, so has Microsoft, but really long before either of them, was something called LXC, or Linux containers. Now Docker is probably the most famous of these. Rocket OS is another, I think put out by CoreOS. At any rate, Linux containers have been around for quite some time, have really evolved lately, and essentially what they are is they're similar to virtualization, but they're not. So what this means is that there is no hypervisor running. So it is a Linux operating system, your choice of distribution that supports LXC, so whether you want to use Red Hat Enterprise Linux or Ubuntu Server, 1404, whatever you choose, you put your Linux OS directly on the hardware, and then you create what are separate containers. So containers are not virtual machines, so they turn on and off much faster, like almost instantly. Essentially what they are is an isolation of what Linux, and actually what a lot of things in the industry call namespace. So this means that they have kind of a separate view of the file system, certainly separate process IDs run in secure sections of memory. They have their own, if you were to do a PS-AUX or whatever your favorite arguments are to see the processes that are running, you would see that each of these containers have their own separate process space and their own separate process IDs, as well as access to separate memory that is isolated and different from the process IDs, the main ones that are running on the hardware in the main Linux OS. So this is essentially what containers are. It allows us to create applications that, and even put binaries and libraries, dependencies, that are not built into the main operating system. They're just built into the container. So they don't have any interaction, in fact, no ability, unless you explicitly create that interaction with other containers or libraries in other containers or other apps in other containers or other processes. So if a process dies, if an application requires a dependency that conflicts with something else, as long as they're running in separate containers, then you're perfectly fine. And on the Linux OS, you are going to have not necessarily a virtual switch, but it is going to, in a similar way, be like that. It's going to be your bridge, okay? So your Linux bridge. So we'll talk probably not too much more about Linux containers. Just know that they're, of course, fully supported with ACI, and we do have other options other than just virtualization.